Welcome to lesson 22. This is going to be our last lesson in this first part of optics. In this lesson, we are going to look at the spectrometer, measurement of the refracting angle A of the prism, and then measurement of minimum deviation D of the prism. So this is what we call a spectrometer. It has this, the collimator, the turntable, and then this is the telescope. The spectrometer is an instrument used for accurate determination of deviation of parallel beam of light which has passed through a prism. This is important in studying optical spectra and for measurement of refractive indices of glass prisms or of prisms, or of glass in form of prisms. Now, we had already looked at the parts of the spectrometer. A spectrometer consists of a collimator, a telescope, and a turntable. And it is on a turntable that we actually place the prism. Let's look at how it looks like. So we have, this is the collimator. It has a slit which is adjustable and also allows in light. And then we have this turntable with leveling screws which are used for leveling the turntable, and then it has also a telescope which has the objective lens, and then this eyepiece lens, and then a cross wire inside here. So before we use this spectrometer, we have to make some 3 adjustments, and these adjustments include the collimator is adjusted to produce parallel rays of light. So we have this collimator which must be adjusted to produce parallel rays of light. And then after that, we are also going to level the turntable. So the turntable is leveled using these leveling screws. And then after that, we shall also adjust the telescope so as to receive light from the collimator on its cross wire. So that's to receive light from the collimator on its cross wire. So after making those adjustments, then we can use the spectrometer. Let's see this. Measurement of the refracting angle A of the prism. So a prism, if you want to get the refracting angle of the prism, you have to first make the 3 adjustments. So we shall have the 3 adjustments made. That is, the collimator is going to be adjusted to produce parallel beam of light or parallel rays of light. And then we're also going to adjust, we are going to level the turntable. We're going to level the turntable and then also adjust the telescope so as to receive light from the collimator on its cross wire. Then after that, we are going now to place the prism on the turntable as shown here, such that the refracting angle is facing the collimator. So it's going to be like this. The refracting angle is going to be facing the collimator. So we place the prism on the turntable such that the refracting angle faces the collimator like this. Then after that, we are going to move the telescope so as to receive light from the collimator. So the light from the collimator is going to be received on the cross wire on the telescope. So you have to move this telescope so as to receive this light, because we shall be viewing through the eyepiece until when the light from the collimator is received at the cross wire. Then we record that position T1 of the telescope. Then after that, we are also going to move the telescope in the opposite direction so as to receive light from the collimator on its cross wire and measure that and record that position T2 of the telescope. Then after that, we are going to determine the angle between T1 and T2, and that angle is going to be recorded as A. as theta, and then we shall calculate the refracting angle, or the angle of the prism A, from A is equal to theta divided by 2. Let's look at the proof for the relation, that is A is equal to theta divided by 2. So here we are going to consider this ray of light, these two rays of light incident on the prism, making a glancing angle alpha and beta respectively, as shown here. So we are going to see that this is alpha, and if this is alpha, then this is also alpha. So the glancing angle here, alpha, is going to be equal to this because they are alternating, and this is the glancing angle beta for this. It is going to be also going to be equal to this. So we are going to see that if this is beta, this is also beta because they are alternating. Then also this ray AB is going to undergo a deviation at this point B. This deviation is D1, and then CD is also going to undergo a deviation here, and that deviation is D2. So when we look at this alpha plus beta will give us the angle of the prism A. Then we know that the deviation for AB is going to be given as twice of the glancing angle, which is going to be twice of alpha, and then also the deviation for CD is going to be twice of the glancing angle beta, which is going to be twice of beta. And then when we observe this diagram, we can see that if this is D1, even this is D1, and if this is D2, even this is D2, because they are corresponding. So D1 plus D2 will give us this theta, and that's going to be the total deviation. And if we replace for D1, substitute D1 and D2 with the alpha, 2 alpha and 2 beta, we shall have theta equal to 2 alpha plus 2 beta, and then we shall get 2 into brackets alpha plus beta, and then we shall combine equation 1 and equation 2 and get theta as 2a, as 2a. So from this we have noted that actually theta is 2a, and we can make A the subject and then get A as theta divided by 2, and hence we would have shown that the angle of the prism is actually half this theta, half this angle theta. Let's look at the second method, using optical pins to determine that A. So here we are going to get a white sheet of paper, place it on a cardboard, and then we shall draw 2 lines on that white sheet of paper. We shall draw 2 lines on that white sheet of paper, 2 parallel lines on the white sheet of paper, and then place the prism on those 2 lines. So it will be like this. So we're going to press the prism such that the refracting angle is facing that side. Then after that, we are going to place 2 pins P1 and P2 on this line BC, and then we shall look through this side QP and place pins P3 and P4 such that they appear to be in line with the image of P1 and P2. So it will be in line with the image of P1 and P2. And then after that, we shall also repeat the procedure for this first QR. For the first QR, we shall repeat the procedure for this first QR, and also place pins P1 and P2 on this line DE, and then place the pins P3 and P4 such that they appear to be in line with the images of this P1 and P2, as we observe from this other first QR. Then after that, we shall remove the pins, remove the prism, and then join the marks of P1 and of P4 and P3 with a straight line, and also here P4 and P3 with a straight line, and then get that angle theta. We shall measure that angle theta. After measuring that angle theta, then the refracting angle or the angle of the prism is going to be got from A is equal to theta divided by 2. Let's look at the measurement of minimum deviation D of the prism. We are going to start by using a spectrometer. So when you're using a spectrometer, we are going to make the 3 adjustments. First of all, the collimator is adjusted to produce parallel rays of light, and then the turntable is leveled and the telescope is adjusted to receive light from the collimator on its cross wires. And then after that, we are going to place the prism, but this time around with the reflecting angle, so with the refracting angle facing away from the collimator, with the refracting angle facing away from the collimator, as you are going to see in this diagram. So we shall have this. Then we are going to move the telescope so that light can be seen. We're going to rotate the telescope so that light can be seen on the cross wire of the telescope. And then after that, we are going to keep that light in view. We shall keep that light in view and then rotate both the telescope and the turntable. Rotate both the telescope and the turntable until when the light begins moving in the opposite direction. So that light begins moving in the opposite direction, and then record that position T3 of the telescope. Then after that, we are again going to rotate the telescope to a new position T4, where it receives the undeviated light from the collimator. And then we are going to determine the angle between T3 and T4, and that angle is going to be the minimum deviation D, mean. So let's make a note here that the position T3 is noted because in the position of minimum deviation, light viewed through the telescope moves in the opposite direction. Then also we need to note that we can use the spectrometer to determine the refractive index of a glass prism. That is by measuring D mean and A, and then using this formula. Which will give us N. So we know that if we have got D mean and A, we shall substitute and then get the refractive index of that glass prism. Let us also look at the second method, that is using optical pins to determine the D mean, the minimum deviation. So here, this time around, we are going to get a white sheet of paper and then place the prism on that white sheet of paper with the with the triangular face on the paper, or as the base so the triangular face is going to be on the base. And then after that, we are going to trace that prism. It will be it will be triangular. We trace the prism, it will be triangular, and then after that we shall remove the trace and then draw a normal to one of the face, and then also measure an angle I may be equal to 20 to the normal. So it will be like this. When we measure that angle I, which may be, we can start with 20 and then we measure that angle, and after that we shall draw a line. Through that angle, and that line will be making an angle of I with the normal. Then we shall place pins P1 and P2 on that line we have drawn, and then we shall replace our prism and then observe through this side QR and place pins P3 and P4 such that they appear to be in line with the images of P1 and P2. And then after that we shall remove the prism and then also remove the pins and then draw these lines through the marks of P2 and P1 and also through the marks of P3 and P4, and where they meet here we shall then measure this angle D, and this angle D is going to be the angle of deviation. Then after that we shall repeat the procedure for different angles of incidence I. So if we started with 20, we shall go to maybe 30, 40, 50 and so on. Then after that you are going to plot a graph of D against I, and it is going to be a curve as we saw in the previous lessons. It is a curve like this. Remember I said we shall talk about that curve, or we shall use that. The curve is like this, and then you remember that if this is the graph is like this, D is here and then I is this side. So the curve here, we get the turning point of the curve and we read on the D-axis that value. So that's going to be the D mean. That's going to be the D mean. Let us also look at the uses of a glass prism. So a glass prism enables accurate measurement of refractive index of a glass material, as we have seen. And also it is used in the dispersion of light emitted by glowing objects. Then it is also used in reflecting surfaces with minimum energy loss. And then it is also used in prism binoculars. Yeah, thank you for your attention. We are going to look at lenses and the optical instruments in the second part of optics. So please enroll for optics too to enjoy that other part.